Hi, welcome to NumPy Tutorial Series. This is the second part of lesson on NumPy array creation routines. In this video, we continue learning how to initialize even huge arrays in a very easy way, in just one line of code.
If you have missed the part 1 of this lesson, check the link in description below. We have already covered many useful functions there.
Before we start, please subscribe to Badger the Teacher and never miss new educational videos. In the part 1, we have covered very simple array creation and initialization routines.
Let's recall them. Array, ones, zeros, full, empty, repeat, tile.
The next widely used function is arange. It creates an array filled with a linear sequence. In the first example, sequence starts at 0, ends at 10, and steps by 3.
A range function is similar to the Python built-in range function.
Exactly. What's important to keep in mind is that the last value is not included. I mean, we have passed 10 as a second parameter, however, as you see, 9 is the largest value in the sequence. We can also specify the data type as we have seen in ones, zeros, and other similar functions. A range function also offers you some shorthands. You can omit both the starting value and the step. By default, starting value is 0 and step is 1. So if you pass only one parameter, let's say 5, starting value is 0 and step is 1. As a result, we get 0, 1, 2, 3, and 4, stopping right before 5. If you pass two parameters, 2 and 5, you provide start and end positions, while for the step, default value of 1 is used. So in this case, we have 2, 3, 4, again we stop right before 5.
These shorter variations are quite convenient, because often needed step is equal to 1.
In the lesson on reshaping arrays, you will also learn how to create two-dimensional array filled with a range function. The linspace function creates an array of evenly spaced values. You provide start and end positions as well as a number of samples. So, in the first example, there are 5 values evenly spaced between 0 and 10. The step was calculated to be equal to 2.5.
I see that by default end value is included in the sequence.
Yes, if you want to achieve behavior similar to a range function and exclude ending value, you should set false to endpoint parameter. The second example excludes end value, as you can see. Now 8 is the largest number in the sequence, not 10. If you omit number of samples, 50 values are generated. So for example, if you provide 0 and 10 as parameters, 50 float numbers that are evenly spread between 0 and 10 are generated. If you don't provide data type, it's inferred from the start and end values.
However, for number, float data type is used, right?
Indeed, if you need integers, you have to provide data type parameter, like in the second example on this slide. There is another useful feature of linspace. You can directly generate two-dimensional arrays with this function. For example, we can pass the first row values 1 and 10 and the last row values 10 and 1 and specify how many rows we want to get, 4 in this case. As a result, we have 4 rows where each column values are evenly spread between first and last row values. So the first column values are evenly spread between 1 and 10, and the second column goes from 10 to 1.
That looks impressive.
The second example is similar, but first column value is actually fixed, because both start and end values are 0, so it's also possible. There are even more opportunities actually. Access is a crucial concept in NumPy. We will return to it in several other videos, but let's briefly introduce it now. There are two access values, 0 and 1, available in NumPy. 0 is a row access and 1 is a column access.
It is very easy to remember, because when we index elements in table, first axis is always row axis, so its value in NumPy is 0. The second is column axis, so it has value of 1.
You are right. What's important to understand is that in NumPy, axis is actually a direction. 0 means that we are navigating down the rows, and 1 means that we are going from left to right through the columns.
So, what happens when we pass axis argument to linspace function?
We choose a direction in which we want to go from starting vector 1 and 10 in my example to the ending vector 10 and 1. We can treat these vectors as rows and build rows between them. Access is 0 in this approach and is a default behavior if you don't provide any access argument. The second option is to treat start and end vectors as columns and build columns between them. This happens when access is equal to 1.
So, in the first example, we are building rows between starting and ending vectors, while in the second example, we have built columns.
You can also create larger vectors, not only 2 values as in previous example, so try it all out and experiment. Don't be afraid of exploring functions and thinking beyond mentioned examples. Please also let me know in comments whether you got the concept of access or not. Feel free to ask your questions because it's very important you start understanding it already. Let's discuss 2 matrix-related functions, I and identity. I allows you to create a matrix with 1s on the diagonal and 0s elsewhere. In these 2 examples, 1s are on the main diagonal. Sometimes it is called also leading, primary or principal diagonal. The first is square matrix with 3 rows and 3 columns.
So, in case of square matrix, we can just pass one parameter, 3. It is enough.
Right. If you don't want your matrix to be square, pass 2 parameters, row number and column number, like in the second example.
Can we fill with 1s the diagonal other than the main?
Sure. You choose diagonal you want to fill with 1s by setting k parameter. By default, k is equal to 0 and it stands for main diagonal. Positive values are for diagonals above the main and negative values are for the ones below main diagonal. In the first example, k is equal to 2. That means that the second diagonal above the main should be filled with 1s. On the picture, red line is the main diagonal, k is 0. Green line is the first diagonal above the main and k is equal to 1 for that. The next one is filled with 1s, it's the second diagonal above the main. Not so difficult. The second example is with negative k value.
Let me try it. We want to fill with 1s that first diagonal below the main, so k is -1.
Well done! Please let me know in comments whether you got the idea or not. There is one more function to fill main diagonal with 1s, but it only works for a square matrix. It's identity function. As you might already got from its name, it creates identity matrix.
Which is square matrix by its definition.
That's why it's impossible to define shape that is not square matrix. That's it for today, so please practice creating arrays and initializing them with values as much as you can. In the next lesson, you will learn how to fill array with random values. Please subscribe to Butker the Teacher and don't miss new lessons. Let me know in comments below if you need some more detailed explanation on topics we have covered. See you in the next lesson. Bye!